Okay, well, good morning. I will be recording our lectures this semester, and they will be available for you on YouTube to review on your own. And so that's what the iPad is here for. I'm speaking into its microphone. I'm controlling the computer with this. And it worked really, really well this summer, so I think you'll enjoy being able to go back and listen to the lectures at your own pace and at your own convenience. Let's go ahead, though, before we get into anything with PowerPoint, just take a look at the syllabus. I'm Dr. Macauley, and this is Biology 105. L and L is our official code, which means that it's a lecture and lab combined course. And your grade is a combination of what you do here in lecture and what you'll do with me in lab on Monday or Wednesday. Am I correct that everyone here is in lab with me Monday morning or Wednesday morning at 9:05? Okay, great. So I'll get to know all of you quite well. There is another lecture that's occurring on Tuesday and Thursday afternoons at 4:15 to 5:40. That's in room 351. 351 is a lecture hall right below the lab. So if you happen to miss this lecture and you wanted to go to that lecture, it'll be the same lecture on the same day, if that works for you. All the labs will be in room 253. My office hours are posted there basically when I'm not in lab or not teaching. I'm in my office or in transition to my office, so I don't think you'll have any problems finding me. In addition to all of those times, I need you to know that every afternoon, Monday, Tuesday, Wednesday, Thursday, I'm in the lab as well, teaching a section that's not connected with you guys, but I'm there. So in addition to these 10 hours, you can always find me in the same lab room, 1 to 4 every afternoon. Okay, so you can always just politely knock on the door and come find me if you needed me for something. My email is there for you, and that is by far the best way to reach me. I check my email often and respond to it quickly. So if you want to contact me, don't bother calling the phone. I'm never in my office, and I rarely check the voicemail. But please just email me. Prereqs. There are no official prereqs for this course. You don't have to have had any previous biology experience, although it does help. And I'll be the first to say that knowing some things will help you, but there is no actual prereq for this course. Students who have taken medical terminology, students who have taken biology or chemistry more recently have told me it has helped in some places, but it's certainly not something I expect you to already know. We will be dissecting fetal pigs as well as some body parts, and that's a part of the lab that you'll experience there. As far as required materials, it's a sticker shock, I know, the first semester for this course. There's a lot to purchase. Keep in mind that what you're purchasing for this course is also what you'll be using in Biology 106. So really you're purchasing 2 semesters worth of books, and maybe that helps justify it a little bit easier in your mind, because I know it's quite a sticker price shock. You've got the textbook package, right? And in the textbook, you've got the Martini visual textbook, and with that came a worksheets paperback book, as well as an atlas that you'll bring to lab. And also in there was the mastering code, right? Very important that you have that mastering access code. And all of that, and I'll go over some of that today and some of that in lab as well. On here it says the course code is, and there's a course code on here, and I've gotten a couple of emails about that. But since I typed this up, I discovered that the best way for you to access mastering is going to be go straight through Blackboard. So I'll go through that with you today, and when you do that, you won't need that particular course code. So I apologize for misleading some of you if you were trying to follow it through this syllabus. So bring the atlas to lab. The worksheets are a really good tool for you to learn by. Some of those you'll be turning in with your lab assignments as well, and you'll learn more about that tomorrow. Then for the lab, there's that big Amerman lab manual, and that also came with a fetal pig book, and I'll talk to you more about that in the lab. And then there are 2 supplements. The blue one is for lab, and the purplish eggplant one is for lecture. And you'll want to make sure you have the lab one with you in lab and the purple one with you here in lecture. You'll also need 6 Scantron forms. These are a particular form 884-E. The bookstore has them. They may not have them out on the shelf, and they may not be the most obvious ones. They're not the ones that are in the vending machines around campus. So you'll have to ask for that specific form at the bookstore front desk. You'll also need for labs, lab you need some goggles and some gloves and closed-toed shoes for a number of the labs. And finally, you want to make sure you have really good access to the internet. That could be, just so I see that form, that is not the correct form. So that's a par score form, so it's not the 8.5 by 11 orange. It is an 8.5 by 11 green form.
Yeah. Oh. You have to tell me because I've been sucking for extremity like a couple of weeks. Really? Yeah. It's like it kind of happened over the summer. It's gonna happen in middle school. You can get out of it because you're just there. Yeah, you just tell me you're sick and
A couple more folks you can reach out to. You'll get a couple other names in lab as well. So now you've got a few contact people to reach out if you have a question or have any problems. In a moment, I know we'll have the tutoring folks come in, and I'll give you some announcements about some other help things that you have as well. Going on in the syllabus. So laboratory, I'll go over that more in the lab, but you'll hear that attendance is absolutely required. You can only miss one lab. If you miss the second lab and you can't make it up, then you will be receiving a failing grade in the course. So I can't tell you how important it is to be at lab and go to your assigned labs. The rest of this is actually quite straightforward. The exams will be given as scheduled. If you have a school-related thing or something you know is coming up, I might be able to work out a makeup with you, but typically all my makeup exams are at the end of the semester. So if you're ill or can't come to the exam, your makeup exam will be at the end of the semester in the testing center. I'll always give you your exams to review after they're done. They'll be available in my office for 2 weeks following the giving it back to you. And then after 2 weeks, then they'll be destroyed. So make sure if you have any questions or challenges that you always come up to the office, take a look at the key, take a look at the exam, see where you went wrong or where you did well, and learn from that so that you can not replicate some of those mistakes on another exam. Oh, turning over, we have quite a few things here to help you be successful. We have a biology resource room. It's a small room. It's off the hallway from where the labs are. It's room 249. And there we have models and microscopes and everything you would ever need to study for this class and for the lab. It's a great place to hang out individually or as a small group. It's also where our walk-in tutors will be. I received that schedule this morning, so I'll be able to publish that and send out an email about that. So now you'll have places to go during the day, during published hours. There's a tutor just waiting to answer questions for you about this course. So please take advantage of that. There's also some one-on-one tutoring available for you, and I imagine the tutoring center is going to come in a moment and interrupt me and make an announcement about that. So I'll wait for them to do that. But just know that we do have one-on-one tutoring available for you, and as a full-time student, you're able to get that 2 hours a week. As a part-time student, you can get 1 hour a week of free tutoring. But if you think you want to tutor, please sign up for it soon. The later you wait, the harder it is to arrange those tutors, to find them, to identify them, and to schedule it. So don't wait to the day before the exam to say, whoa, I'm in trouble. If you think you would benefit from a tutor, go ahead and sign up, get it started. It takes a week or so to get it even going. The rest of the language is exactly like you would find on the lab syllabus or most of your syllabi on campus, basically telling you that we're accredited, reminder to check your email often, and that we expect you to behave in a wonderful way, and that we value your integrity and expect your academic integrity, not cheating or plagiarizing others' work. There is a dispute resolution process in place if you have any concerns with me or the course. That protects both you and me. I'll show you Blackboard in a moment. So if you're not familiar with Blackboard, it gives you a quick little tutorial there, but I suspect most of you are okay with that, but I will show you how to go into Blackboard and go into mastering here in a moment. Notes about the lecture, bottom of page 5. I expect that you're here, and if you're not here, that you are diligently going to be watching the lectures at your convenience on YouTube. Every once in a while, people decide they're just going to become sort of hybrid students and do this on their own. And rarely, occasionally, someone can do that very, very successfully. But there is something about coming to lecture and the discipline of coming to lecture and listening to what's going on that really does seem to help students be more successful. So I would encourage you to make this a priority to be here for lecture. And when you cannot be here, just know that the lectures will be posted. I will send out a link. There'll be a place on Blackboard, and I'll have the YouTube link where you'll find this lecture posted. It is really a great idea if you'll look through the textbook before we get together on that particular section. If you've had a chance to look at your textbook, it's called a visual textbook for a reason. And for years I used a, quote, more traditional textbook, and that textbook had long paragraphs and page after page of text, and students told me they just weren't using it as much as I would expect. And so I've switched over to the visual textbook, and it's just like it says. It's very, very visual with just little paragraphs of information around the pictures, and it's something you can sit down and get a lot of information out of very, very quickly, and you don't have to worry about reading 10 pages of text to get something. So it's meant to be sort of hodgepodge, pick up pieces in here. So I really encourage you to open the textbook and look at it and use it as much as possible. There is a lot to cover. And there will be occasionally a time where I'll say, you know what, you need to go look at that on your own. It'll be pretty straightforward material, but there will be some of those moments. On the next page, page 6, we do expect you to take the exams on time. Again, you'll need that 884-E form. And the exams are sort of multifaceted. There'll be a small written part. There'll be a visual part, always some PowerPoint images to label. There'll be some vocabulary, some fill in the blanks, some multiple choice, case studies. So it's a pretty thorough exam as far as different types of questions, and I think that helps different types of learners as well. Again, on exams, if you have any questions, just ask me, basic stuff like that. Attendance policy, again, labs absolutely required. Lecture, I don't take attendance. There's no points for being here, but I think you'll benefit from being here for lecture. Students with disabilities, if you have any sort of documented disability, if you received any special services in high school or think you might be eligible for those, I can't do anything for you. I will be glad to listen to what your limitations or your concerns are, but I can only work through the Office of Special Services. So if you think you qualify for something like that, room 101, go up there and they'll talk to you, and then they'll let me know in full confidence that you are a student who needs extra something, and they'll fill in the blank for me, and I'll make all that happen for you. To do well in this course, I really think that this is a course that requires some dedication of time. It's not that the content is that difficult, but there's a lot of content. And what I hear people saying when they're not as successful as they are is, I wish I had spent more time. So I think you need to have, especially when we get a little bit later in the course, you need to have a lot of repetition. This is a lot of learning. And I hate the word memorizing, but there is memorizing involved as you learn muscles and bones and structures. And learning, at least for me, takes a lot of repetition. So it's the kind of thing where if you'll come to lecture, maybe listen to the YouTube lecture, then do the quiz, do the homework, come to lab, do the pre-lab. By doing all of those activities, you will have done the repetition that's necessary to be successful. So just know you're going to be asked to do some things over and over and over, and it's going to seem, oh man, but you're learning as you do it. Okay? If I didn't have all those activities, you would have to go do that on your own anyway. Right? So some people don't like being told you have to do this homework assignment. I'd rather just do it on my own. And other people really, appreciate being pushed and being told to do things 3 and 4 times. So we all have different personalities. But just know that as you do it over and over, you are becoming more and more fluent with the content. Ask questions. Please just raise your hand, ask a question. We'll get to know each other, so there'll be a lot of time in lab as well to ask questions about lecture and lab. Cell phones, maybe I'm old-fashioned, but I really don't want to see them or hear them in class unless there's some real emergency that you're anticipating. So please have them put away. Let's take a look at the schedule on page 7, and it goes over to page 8. This will be our lecture schedule, and you can see that here it is, Tuesday the 8th, or the 26th of August. We'll be talking about the introduction to the course and a little bit about the human body, and that'll be found in Martini, 2nd edition, chapter 1. By Thursday, I hope to be on to most of chapter 2, and we'll be finishing that for a little while. Now, next Tuesday, we have a holiday already. So you don't have any classes next Monday or next Tuesday for the holiday. And so we'll have a couple of lectures this week, only one lecture next week, and then we come back 2 weeks from today and have our first exam, okay, as you see on the schedule. Now, the first exam is going to cover chapters 1 and 2, so that's the intro material and the chemistry portion, plus vocab 1 through 16, and I'll describe what that means. There will be some slides of some vocabulary prefixes and suffixes that I use throughout the course, and you'll be responsible for the first 16 of those slides. and I'll go through that with you in a moment. I have all the test dates bolded on the calendar, and so please go ahead and mark your master calendar. Recommend just getting out a calendar for all of your classes and marking all your deadlines on there and your exam and quiz dates, and let me know as soon as possible if there are any conflicts. As we go through the course, you'll see that we'll be done sort of the second week of December, and they never publish the final exam date, but I suspect, thinking about my crystal ball and the historical, I suspect our exam will be on Tuesday, the 9th. I don't know that for sure. So go make flight reservations and stuff on that. But I suspect it's going to be on Tuesday, the 9th of December, but that's not confirmed. Okay. Any questions at all? Schedule, syllabus, anything at all? Materials, lab? Hold on to this. This is also posted on Blackboard for you if you need to look at that. In fact, let me go ahead and go through a couple of slides here with you. Right now, open up your course pack, your lecture supplement. That's the purple colored. And this is what you want to have with you each and every time. And let's go ahead and open that up to the very, very first page. And you'll see, let me just introduce you to what you have there. The very first page in there, well, after the copyright page, is a page that says something about study suggestions for an introductory biology course. I'll be going through that with you a little bit in a moment, but I have a lot of students who always say, Mac, it's been a while since I've taken a biology course. I'm a little bit nervous about it, or I'm not quite sure how to approach a college-level biology course. What do you recommend? This is a really short 2-page story written by a guy. I've lost track of the original author. The last link I have is from the University of Georgia. But he or she makes some really good points about how to approach a class. I'm not going to read it to you, but I ask you to read that two-sided paper and ask yourself, are there some things in there that you could add into your own study skills or study time that might help you be successful? After that page, then you get to what we call the objectives. And there are a series of, basically, study guide, right? A series of objectives. These are the things that we'll be covering this semester. Every once in a while, there'll be something in there that I don't get to, and I will certainly add to that. But that's the base core of what this course is all about. And when you go to transfer this school, let's say you were going to transfer this course to a school that we don't normally transfer to, they would write me and say, show me the syllabus and what were the objectives of the course. And we could then send them, hey, this is what this course involved. Here are the textbooks we used. Here's the lab book we used. And I can assure you they would then transfer this course. It's a very good course. Right now this is going to University of Michigan, MSU. This course is traveling and transferring to other schools very, very well because of how strong it is and because of the objectives that we can give them. So that's basically a study guide for you. So once you go past all of those pages, keep on going. Then you should get to the PowerPoints or the vocab. I forget what's next. There's going to be a little section, vocab. So then after the purple divider, you get to a section of vocab slides, and I'll be going over those every single lecture, sequentially from the first slide through the 100th slide. And on the first exam, you'll do the first 16 slides. I'll show you how to prepare for that in a moment. And then go to the next purple divider, and then you begin the lecture notes that I'll be walking you through, the PowerPoint notes. So make sure you have this supplement with you at each lecture and have it out when you're studying as well. So let me see. Just a quick reminder here on the PowerPoint. So everyone's got their textbook or their Amerman lab manual. If for some reason you go to the bookstore, I know they have plenty of textbooks, but if you go there and they don't have something that you need to let them know that it's not on the shelf. So you have to put in a special order, or else they won't know to go get more. So just as a word, if anyone's listening and doesn't have a lecture supplement, and you didn't tell the people at the front door at the bookstore that they didn't have any on the shelf, they're not making any more for you. So make sure you let them know if you need something that's not on the shelf. There is a quiz the first week in lab. Monday folks have already dealt with that. Wednesday folks, you'll have that quiz tomorrow. Just make sure you do your pre-lab. If you have any questions about that, ask me afterwards. So here's just a quick visual of the books that you have. So the textbook, the Visual Anatomy and Physiology book here, Through mastering, you'll have a program called PAL 3.0, that's Practice Anatomy Lab. You have the Atlas, please also bring that to lab. Next week we won't use it much, but the third week and beyond we'll be using that Atlas quite a bit. You also have your Amerman book and the Fetal Pig book. And the Fetal Pig book you don't need to bring to first lab. I'll tell you when that is. Let me see, we've gone through the syllabus, so we've gone through sort of the course goals and objectives. There is a website that's linked off Blackboard, the Mastering AMP site, and this will bring you to a lot of study skills and study activities, and I'll show that to you. We've gone over all the policies and grades, and please mark your calendar for everything. And then I mentioned that I'll be using these vocabulary terms. It's really not a medical terminology course at all, but I do want you to be able to look at a word and break it down a little bit. And by being familiar with the prefixes and suffixes, it'll really, really help you in your learning of this material. Just a little bit about myself, and I'll get to know you all, but have my master's and my PhD from the University of Florida, PhD from the University of Florida College of Medicine, and there my emphasis was in wound healing and biochemistry of diabetes. And from the University of Florida, I got my first faculty position at Washington State University. So we went out to Spokane, Washington, and there I was in the Department of Genetics and Cell Biology. My wife also received her PhD from the University of Florida in speech-language pathology and neuropsych. So she's the director, the clinical director of the Speech Path program at GVSU. So if any of you are thinking about going into Speech Path, you'll definitely be talking with my wife at some point over at Grand Valley. We then found ourselves at the University of Alabama in Tuscaloosa for about 6 years. And then I was called over to Oklahoma Wesleyan University, where I taught for a while. And finally now we're in Grand Rapids. So we have 5 kids, one who just finished nursing here, one who's over at Grand Valley, pre-med, a high school junior, got to get the right grades, a middle school 7th grader, and a guy going into 1st grade. So we've got a little bit of everything in the family. So I understand busyness, and I understand all those distractions that go with that. But I really do enjoy teaching, and I enjoy seeing you be successful and moving along. So I always like to hear back from my students who are off now at other schools and are in other programs. As far as being successful, I've got just about 5 or 6 slides here. I'm not going to read this to you, but you can look through this. These are sort of like the survival skills, how to be successful. Most of these apply. Number 1, come to class, right? Come to lab. It's pretty obvious. Number 2, budget your time. Some people have a hard time with this, but you want to actually pencil in your study time. You want to pencil in when you're going to go to the library. And I think if you have a schedule, it's much easier to do that. And when you're there, find that right place. Are you a person distracted by people? If so, go to a corner. If you want music, don't want music, whatever it is. But just be mindful of your own learning skills and how you study well and get into a habit and establish that early. Be a good reader. It seems like we're in this day now where people don't read. They just look up something on Google and they get a little fact and that's it. And they don't really read for deeper understanding. I think you'll find the book is kind of that way too, right? It's little pieces here and there, but you still have to take the time to synthesize all of it. So ask me questions. When you're reading through the book, look for those bold-faced terms. Look for the italicized terms. Look for this. Don't forget about those chapter summaries and those reviews at the end of the chapters. Use these worksheets. These little worksheets are very, very good as far as pulling the information together for you. Not reading through all of it. Be an active listener, right? If I say it 3 times, it must be important, right? So be listening. You have the PowerPoints in front of you. And so how you use those is kind of a personal thing. But if I say something a few times, you want to be making a note that I said it multiple times. It must be important. If we have time, get involved with a classroom discussion. Please raise your hand, ask questions. If it's not something I can answer, I'll tell you. If it's something I don't know, I'll certainly tell you. And if we don't have time for it at that moment, I'll say, let's move that off to lab. Let's talk about that at lab. We'll have more time there. Take some good notes. Now, I'm giving you your PowerPoint notes. And some folks, many great educators, suggest that this is the absolute worst thing I can do, is to give you PowerPoint notes. Because it creates basically, what's the right word? A laziness on your part. Because what did I do? I went through the textbook and I took the pictures and I put them next to the information and I distilled everything down into its most important stuff and I put it on a slide. I spent hours and hours and hours creating these PowerPoint slides, and that's really what you need to do yourself, right? You need to read the book. You need to distill the information. You need to match up the content with the pictures and make sense of all this. And sometimes some students, not all, but some students become very, very reliant on the PowerPoints, and they don't really ever synthesize the information. What they do is they read through it, they know it, but they don't know it, right? They're familiar with it, but they don't know it. So it's important that you don't fall into that hole of depending too much on me to distill the information, that you actually are learning it, not just becoming familiar with it. You probably won't have time to recopy all of your notes, but I think by the time you do the other activities, you will have done basically this repetition that's necessary. And then forming a study group, I can't suggest how strongly, I can't strongly enough say how important that is. Some people do this all on their own, but I think if you'll find somebody who's in lab with you or somebody you know, and just commit to going into the student resource room together or studying outside of class, you'll find it much, much easier to do this as a team. Some classes, I think, if it were, some classes I think it'd be better to be by myself, but in a class like this where there's a lot of hands-on and a lot of quizzing back and forth, it's really, really helpful to have somebody else alongside you working through this. So if you don't know of anybody else in the class after the first week or so, get with me. We'll try to establish some study groups if you want to do that. And then as you're going through lecture, listen to the who, what, where, why, how, all those kinds of things. Ask yourself those questions. Why is he saying this? How does this connect with everything else that we're doing? When you're getting ready for exams, please know that I am not going to be asking you minutia questions from things that I've not discussed. Right? I'm only going to quiz you on those things which I have directly discussed here in lecture. So if you come across something in the textbook or something in the homework that, man, he hasn't talked about that, don't worry about it. Okay? Once in a while I'll have a question or two in the homework that is a little bit outside of what we discussed. It's good for you to know it, but it's not going to be something I'm going to test you on when we get to the exam. So knowing that, when you get to the exam, just relax. There's nothing on there that you shouldn't know. There's nothing on there that I'm trying to trick you on. You just need to think, okay, he must think that I can do this. So I know A and I know B, so that must somehow get me to C. So just be confident with what you know. And just know that I don't recurve the class or anything like that. So all of you can do really, really well in this class. I mentioned that Darley paper, that one two-sided paper at the very beginning of your course pack. Do read through that. On the first exam, I will ask you a couple of questions about that handout. So don't forget to read through that. At the end of it, there's actually a question that says, from this handout, how will I approach my class differently? What have I learned from this handout? Please be prepared to tell me what you learned from that Darley handout. Okay, so I mentioned that there's vocab, so I'm going to skip back right now to the vocab slides, and you can do the same. Go back a little bit earlier in your course pack, and there you'll see some vocab slides. They're numbered 1 through about 101. I'll go through 4 or 5 of these slides every lecture at the beginning. I've got them alphabetized for the most part. And what you'll want to do to be successful for this is make some flashcards. I think flashcards are by far the best way to approach this. So get a pack of flashcards. You can just do the half flashcards, the little tiny ones. I would not recommend the flashcards that are wire bound because you can't make stacks with them, right? But I just think loose note cards with a rubber band around it are great. And all you'll want to do on your note card is on one side put A, and on the other side put without or lacking. You're not responsible for knowing or memorizing the example. It's just there to, think about something, but you're not required to know the example. Just know that if you see a word starting with A, it often is a negating term that means without or lacking. If you see a term that has AB in the beginning, it oftentimes means away from, as an abstinence, to move away from something. Able, as a suffix, is capable. So something that's viable is capable of life. You will learn later that via means life. AC on the end of a word means pertaining to, so cardiac, pertaining to the heart. And acetabul, we'll see this term in the bone lab later on, but it literally means vinegar cup, and you'll see that the acetabulum is the hip socket that the femur, the head of the femur, fits into the pelvis. So just know that acetabul means vinegar cup. Okay, very literal, just know these. Acro, extremity. If you acromegaly is a condition like Shrek or Andre the Giant where their extremities become very enlarged. Acou, pretty straightforward. We've heard of acoustics, hearing. A dip is fat. And AD means toward or near to. If you're in the gym and you're doing an adductor machine, adduction, then you are moving toward the middle or toward the midline of the body. Adeno is referring to a gland. Adenoma would be a tumor of a gland. Oma means tumor. We'll see that later. But for now, just know that adeno or aden means gland. Aero is oxygen or air. If it ends in AL, just like AC, it means pertaining to. And AF means toward. We'll see a lot of this word afferent or afferent later in the course. And it means that something is moving toward something. Albinos are white. So albi means white. Albinuria would be a very whitish or pale urine. Aliment means nourishment. And your digestive tract is sometimes called the alimentary canal because it's along that canal that you gain your nourishment. Algia is a painful condition. Myalgia would be a painful condition of muscle, myel. And alveole is a small hollow cavity. And you may know that in your lung you have all these little air sacs called alveoli. So a small hollow cavity. Ambi, like somebody who's ambidextrous, both sides, can do things on both sides. So how will I quiz you on this? For example, I would say to you on the exam, what would ambialgia mean? So I take a prefix and a suffix, put them together, and what do you say? For 2 points, ambialgia is pain on both sides. Okay, so that's the way I'll approach this, and that's how I'll quiz you on this. You can do the same thing with your note cards. Take your cards and basically, okay, just start putting them together. What would that mean? If these two were together, what would that mean? If these two were together, what does that mean? I'll go through one more today. AN is just like A. It's another negating term, meaning without or lack of. Anesthesia, a lacking or absence of pain. Andro, male. Androgens are the male hormones. Angio, vessels or pertaining to vessels. And then finally, aqua is water. So every every lecture, I'll go through 4 or 5 of these. Before we see each other for the first exam, we will have gone through 16. So you want to go ahead and make up your flashcards through 0. Go ahead and make them up. A through 0 will be on the first exam. This will be fill in the blank on the exam, and I will just simply take these terms, like I said, and put them together and ask you, what does it mean? Questions on vocab. Again, it's alphabetical, so it's a little bit awkward in the beginning, and I think the vocab gets easier because as the course goes on, we've discussed more and more of these terms, and we've seen these terms in our vocabulary. So it gets a little bit easier, but go ahead and make your note cards up, and every day, I just suggest look through it every day. Look through it every day a couple times. And you don't have to wait for me to go through these. And, I know it, I don't know it, right? And then pick up the ones you don't know, go through those until you know them. And then if you flash through those every day, then by the time the exam comes, you've got the vocab down. You're not even worried about it. You're not thinking about it. You're not stressing about it. And the night before the exam, you're not stressing about vocab. So this is something you can certainly be doing along the way. Throw a little backpack, a little set of cards in your backpack or your purse, pull them out at the traffic light, whatever, and just quickly go through them. Don't do it while you're driving, but traffic light's okay. Okay, so back to the PowerPoints, and let's talk a little bit about anatomy and what it is that you signed up for. Any questions? Anything at all? You guys looking forward to a good semester? I'm looking forward to a good semester. I hope winter stays far away. I was listening to the radio this morning on the way in, and they're talking about how this summer we haven't reached 90 degrees yet, And the last time we never reached 90 degrees was 1951. I wasn't around then, but apparently 1951-52 winter was rough. And it was a really, really bad sign of the winter to come. So if we follow in that pattern, then it's going to be a rough winter. And they said, we'll know it's going to be a rough winter if it starts snowing in the middle of November. So usually our fall is right. The first December is when we get our first big snowfall. If our first big snowfall is in the middle of November, we might be, looking like that 51-52 pattern, which could be a really ugly one. They said it'll be last year's snow plus 2.5 feet. So, and last year was pretty rough. So anyway, hopefully, right, we don't have that. And we have a nice, long, mild fall, and we're not dealing with snow for a long, long time. Okay, so let's figure this thing out. Anatomy. Anatomy is the study of structure. So the pieces, the parts, all of the parts of the body. And I'll tell you now, every little part of your body has a name, and sometimes more than one name. And we won't learn all of them, but we'll begin having a pretty good vocabulary of the parts of the body. It comes from the word, anatomy does, from the Greek meaning to cut up. And that's exactly how we have discovered about ourselves. We do dissections and we cut up specimens, and by doing so we learn. So that's how it was done historically. Then the other half of this thing is physiology. And physiology is a study of how things work. How do those pieces go together? What's the function of these? And what we'll discover is that the body is divided up into 11 different body or organ systems. You've seen this if you've done your pre-lab, and we've talked about these a little bit. And it's really difficult, if not impossible, to separate anatomy from physiology, which is why they're typically put together. You can take a purely anatomy course. It's a lot of memorization, just pieces and parts, pieces and parts. Or you can take just a physiology course. I like that we've kind of put it all together. And we'll see how we really can't separate anatomy from physiology. I always use the analogy, you can talk about a bicycle, and you can sit there and name all the parts on a bicycle. It's kind of boring, right? But that's anatomy. And then you can do physiology, which is, okay, how does one get on the bike, and how do the gears work, and how does this whole thing work? That's the physiology. But we have to know both sides, don't we? So you really have to appreciate both sides simultaneously to understand how someone gets onto a bike, name the parts, and make the darn thing go forward. I'm not going to quiz you on these names. I just want you to know that anatomy is a very rich history, and that Aristotle, back in 300 or so BC, was the first person to write about complex structures. I'm sure other people thought about it, but he gets the credit for it. And he wrote a book called Of Parts of Animals. I remember reading this book. It's a very small book in high school. And basically he argued that everything in the universe is made up of simpler things, right? And we'll talk about some of that hierarchy of structure as we go through this morning. Herophilus comes along, also in antiquity, and he was doing a lot of human public demonstrations and dissections, and his work was thought to be groundbreaking and very important all the way up through the resonance. I can't say it. Why can't I say it? Renaissance, sorry. Get my syllables in the right place. Can you imagine, if you've ever been to Greece? It's hot, right? It's hot. And I can't imagine doing a gory public dissection out in the heat. It just doesn't sound like a good time to me. Galen comes along. He is after the time of Christ, and he was a Roman who, at this point, though, started doing dissections, but they thought that human dissections in the public were too gory, and so now we were using animals to model human. Now, when we do the fetal pigs later this semester, you'll see that, yeah, there's a lot of similarities, right? I mean, pigs have intestines and a stomach, but there are also some very different things, and if we relied upon animals to learn about human anatomy, we would have some problems. And so this was not the best thing, but there were many mistakes perpetrated or continued through history because we thought that humans must be a lot like smaller animals. Oops. And then probably the most famous I think, as far as drawings go, of the old days was Leonardo da Vinci, who you've seen this Vitruvian Man image before. I've given you a website link here, just some beautiful drawings. It's amazing how detailed they were, and you would learn a lot just by studying da Vinci's sketches. Then we finally get up to Vesalius, and he was considered the sort of the father of modern cadaver dissection, and this is still what's in play now. So if you go to Grand Valley or go to Michigan State or Michigan, medical students, physical therapy students, whatnot, are in the lab with human cadavers, learning about human anatomy, and that's still the model that we have now. So I think interacting with human cadavers is very important later on. Here, though, I will say we don't have human cadavers. We're hoping to get some plastinated cadavers in the near future in the new building. But our models, we have a very nice selection of models. And you will leave this course knowing your anatomy very well just by using the models, I assure you. So macroscopic versus microscopic anatomy. Macro, big, micro, small. So we're dealing here with what it is we cannot see with the human eye. We have to use a microscope to see cells. We have to use a microscope to see tissues. When you're studying cells, we call that cytology. We'll look at some cells next week in Lab 2. Then histology is a study of tissues, and we'll spend all of Lab 3 looking at tissues. That all requires a microscope, so it's considered microanatomy or microscopic anatomy. If you're going to be using your naked eye, however, to look at body parts, that comes under macroscopic anatomy, and you might also refer to it as gross anatomy. This hierarchy on this slide is very important, and this is sort of what Aristotle was going back to when he said we are made up, complex beings as humans are made up of simpler, less complex parts. And this hierarchy also describes what we'll be discussing in this course and even the way that the textbook is arranged. So when we get to Chapter 2, next time, we'll talk a little bit about what is an atom. All right, we'll go into some basic chemistry. And what is an atom? Something like carbon or oxygen or nitrogen. And then we'll see that those simple atoms, or those atoms, can combine to make simple molecules like water, H2O. Right? Hydrogen and oxygen combine to make water, or CO2, carbon dioxide. There's a couple layers that are missing on here, and I'll mention them now, and I'll mention them again in a moment, but I'll add them onto here. After you have the simple molecules, there's then macromolecules. Now, macromolecules, as the name suggests, are just larger molecules. And then, after macromolecules, I want to add one more layer, and that is organelles. So your cells have within them organelles. And then those organelles are critical to making cells. So you see, I added two more layers of complexity, if you will, in between molecule and cells. So then we get to cells. Well, cells, we have trillions and trillions of cells in our body. And then those cells are the building blocks of tissues. And we'll talk about tissues in a moment. And the tissues are the building blocks of your organs, like the heart, the liver, the kidney, the brain. Those organs combine into different combinations called organ systems or body systems, like the digestive system or the cardiovascular system or the urinary system. And then all of those 11 systems, 12 systems if you count the 2 reproductive systems, then combine to make the organism, right, at our level. So this is the basic hierarchy, and I'll refer to this as the atom, A-T-O-M, to atom, A-D-A-M, continuum. Okay, so the atom to atom continuum of complexity. So let's go through this, and this is just about one slide or so per level of complexity. This is all introductory stuff, but I think it'll make sense to you, and you'll appreciate now why the course is set up the way that it is. how many in here have had chemistry? Okay, about half, maybe a little bit more of you have had chemistry, and some of you have not had chemistry, and when I say that word, you start to sweat, right? It seems to be one of those words, calculus and chemistry. Those two words seem to make people sweat a little bit more, and maybe anatomy too, I don't know. But you may have seen this chart before. This is a periodic table. This is a basic organizational tool that describes or organizes all the elements on our Earth, and elements are made up of atoms. So atoms are described as being the smallest unit of matter. And we see on this chart, on here you see C for carbon, and there's N for nitrogen, O for oxygen, things that you've heard of before, and we'll come back and look at it just a little bit. Now, these different atoms, like carbon and hydrogen and nitrogen, combine to make molecules. So 2 or more atoms can combine to make water or sugar or a vitamin, very simple molecules, basic molecules. Those basic molecules then become the building blocks for larger molecules, and this is where I added it on that. So the macromolecules, these are larger, more complex molecules such as DNA or proteins. Those macromolecules, the DNA, the proteins, the carbohydrates, they now become the building blocks for the organelles. I also added this layer into that previous atom-to-atom continuum. And the organelles are things like the mitochondria, Golgi apparatus, the endoplasmic reticulum, even the nucleus, all the pieces and parts of a cell. Each has its own job, and those parts are called organelles. The organelles then combine to become the building blocks of a cell. Now again, you have trillions and trillions of cells in your body. These are the smallest living structure in your body. So each cell is considered its own living entity. Everything before this was non-living. Cells now and beyond are considered living. The cells, you can have, epithelial cells or a muscle cell, but turns out now those cells are going to combine into tissues. And tissues are a bunch of cells that have a common function, a common theme, and we'll go through the 4 different types of tissues here just to introduce these to you. In lab, we'll spend time looking at these. In lecture, we'll discuss this a lot. So within your body, you have 4 basic types of tissues. First one, in no particular order, connective tissues. And as the name suggests, they hold us together. They connect us together. Examples of connective tissue include bone, cartilage, blood. What I don't have up here is fat. Okay, so fat is considered a connective tissue as well. Pretty broad group, and we'll see these quite a bit in lab. The second type of tissue is muscle. Muscle tissue, special kind of tissue. Muscle tissue is unique in that it moves, right? It can contract and change shape. And it turns out there's 3 different kinds of muscle tissue. We'll look at them all under the microscope later in the course. There's skeletal muscle that moves your skeleton. There is smooth muscle that helps move your digestive products through your gut. And there's cardiac muscle that's responsible for your heart pumping. The third type of tissue, epithelial tissue. Epithelial tissue is what covers your body, like your part of your skin. Epithelial tissue also lines all of your body cavities, lines your gut tube. For those who are in lab Monday, we talked about the serous membranes. Those serous membranes, the pericardium, the peritoneum, and the pleura, those are epithelial tissues. And then nervous tissue. It's unique in that it can conduct electrical signals. And this is found largely in the brain and the spinal cord, but it's spread out throughout your body. So we have 4 basic types of tissues: connective, muscle, epithelial, and nervous. And we'll learn what they look like under the microscope and their different functions. We'll label some of their parts as the course goes on. If I had a heart in my hand, right? It's an organ. And as I dissected that heart, took it apart, I would be able to find evidence of all 4 types of tissues. So tissues combine to make organs. So if I have a heart, I can find some epithelial tissue, some muscle tissue, some nervous tissue, and some connective tissue within the heart. If I had a bone, if I had some skin, if I had a brain, if I had a kidney, it wouldn't matter what the organ is, I would be able to find each of these different types of tissues in a unique arrangement. These organs then will combine into the organ systems or the body systems, and we'll name and recognize these systems. And again, there are 11 different organ systems, 12 if you count the 2 reproductive systems. So let's just go through these quickly. What you'll want to be able to do when you see these images is, one, name it. So when you see these images again, name it. These are images very, very similar. They're not exact, but they're very similar to the ones you have in your Martini textbook, and they're very similar to the one you have in your Amerman lab manual. So when you look at this image, you should see the integumentary system, and you also need to know the major organs, what's involved or what's included in the integumentary system, and that's going to be the skin and the hair and the nails. And then you need to know, not all, but know or recognize, I should say, the physiology, the functions of these systems. The exam will not say, list the 4 functions of the integumentary system. Okay, that's not how the exam will be set up. It would instead say, which of the following is not a function of the integumentary system, right? Something like that. So you need to be able to recognize these, not be able to list them all. So it would say, which of the following is not a function of the integumentary system, and maybe I'd have something in there about, I don't know, movement of something. I don't know. Something that would be very obvious it doesn't belong. So the integumentary system is providing protection, certainly for your body, but it's also where all of your nerve endings are, right? So your ability to perceive touch and all of those nerve endings are in your skin. It's also where you are synthesizing vitamin D, which is why many of us in the wintertime are vitamin D deficient, because we don't have sufficient sunlight to make the vitamin D. It's also obviously preventing water loss. The skeletal system, pretty obvious to recognize, lots of bones, but don't forget this is also where all of your blood cells are being produced. That process is called hematopoiesis. And we'll talk about hematopoiesis later on, but the making of blood. This is also the system that is storing your calcium and your phosphorus. And I'll allude to it a lot this semester, but in Biology 106, you will appreciate how many very important processes require calcium. So for you to have your nervous system working, for your muscles to work properly, for you to heal your wounds, all of those things require calcium. And you'll appreciate how important the bones are to those functions later on. And obviously the skeletal system works with the muscular system. Now when you hear the skeletal system, I want you thinking protection, support, structure. Obviously the bones are connected to the muscles. The muscles allow for the movement. So on the bottom there, yes, they allow for body movement, but I want you to keep movement over on muscles and keep the word structure and support on the skeletal system when you think about their functions. Some books refer to the musculoskeletal system as one. Okay, and I'm separating those two. The muscular system, all the muscles of the body, we'll be learning about 45 or so muscles in Lab 5. Going back, we'll learn all the bones of the body in Lab 4. And this is the system that's not only allowing us to move, but also generates heat. So if you're cold, you're going to get up and move around, shiver a little bit, cause yourself to raise your body temperature. The nervous system, in here you see yellow structures. Yellow is the universal color for the nervous system. So if you see a bunch of yellow structures, it's almost always nerves. This would also include the brain and the spinal cord. We'll spend about 4 chapters in the textbook talking about the nervous system this year. And we'll have a really nice lab on the nervous system. This is the system that's going to be receiving all of your environmental information as well as perceiving and then causing your movements of your body, also responsible for your memory and intelligence. The endocrine system. This is a series of glands found throughout your body that are producing hormones. So this is going to include the pancreas, the thyroid, even the stomach and the heart make some hormones. And these hormones are going to be necessary for a big word called homeostasis that we'll talk about in a moment. I'll put the word homeostasis on here right now, though. So these hormones are going to help maintain homeostasis. Cardiovascular. I see a heart. I see red and blue. Definitely the universal colors of the arteries and the veins. In lab, you want to at least have a red and blue pencil. Red and blue, there will be a lot of things that will require color-specific things. So later on in the course, make sure you have at least a red and blue pencil, red and blue marker, red and blue dry erase marker for lab. But remember, not only are you pumping blood, but you're also distributing hormones, nutrients, gases, waste products. All of that is being distributed throughout the body by the cardiovascular system. The lymphatic system, green. Now you see green. Those are not green nerves. Those are lymphatic vessels. And along the way, you'll see little lymph nodes. There's also the spleen and the thymus, the tonsils. These are all structures of the lymphatic system. They are collectively working to establish your immune system. So very, very important part of your immune function. The respiratory system, we recognize this one, a couple of lungs, all involved with gas exchange, the incoming oxygen and the outgoing carbon dioxide. The digestive system, also not difficult to recognize, I don't think. You see the stomach, the liver, the intestines. All of these organs are working together to take in, break down, utilize energy, and get rid of wastes. The urinary system, a couple of kidneys, the ureters, the bladder. The kidneys are filtering the blood and are creating the urine. And we'll see how important those kidneys are. This will be later in the course. Then the two reproductive systems, the male reproductive system with the testes, the production of testosterone, so that's endocrine, we're making hormones, but we're also making sperm for reproduction. And then the female reproductive system, the production of eggs. The breasts are included in, the mammary glands are included in the female reproductive system, not only for reproduction, but also for nourishment and development. So we've got those pictures, and when you see these images, right, you need to be able to name it, name the image or the system when you see it visually, be able to tell me what are the organs within those systems, and tell me what the functions are. Again, not as a fill in the blank, but more as a multiple choice or which one does not belong type of idea. You'll also be seeing these systems in lab. So you'll have no problem by the time we get to the first exam recognizing and knowing these systems. Any questions so far? Doing okay? Please don't hesitate to ask. Now, when you take all of these 11 systems and you combine them, we get the organism. Now, in a human anatomy course, we're thinking about the organism on the bottom right? We're thinking about a human. But let's not forget that if this were, this is a biology course, that the same hierarchy would be found in a whale or in a flower or a honeybee. Slight differences, but for the most part, the same kind of hierarchy. And we also don't want to forget that some organisms are single cells. So all of this story about, tissues and organs, that's not a necessity for life, is it? Life can be a single cell, as in an amoeba or a paramecium or a bacterium. So that's an atom-to-atom continuum. Know that well. That's sort of the buildup of anatomy. Now let's talk about probably the most important concept in physiology. How things work. And what your body is desperately trying to do is to maintain your homeostasis. Another way of thinking about it is no matter how cold it is outside, no matter how warm it is outside, no matter how long ago you had a meal, your body is trying to keep your blood pressure, your heart rate, your glucose levels of your blood. It's trying to keep those things relatively level. Not perfectly level, but within a normal range. And this is the idea of homeostasis, is that every system of your body is contributing in some way to keeping your internal environment constant. Homeostasis is maintained by an idea called negative feedback, and I'll show you a slide to demonstrate that in a moment. And when the body can no longer maintain homeostasis, you're seeing a doctor because we have a disease for that. So when you no longer can maintain your blood pressure, right? When it no longer stays within a normal range, we're seeing a doctor. We've got a disease, a condition. When we no longer can maintain our blood sugar, maintain our respiratory rate, you name it, whatever it is. But when our body can no longer maintain normal levels, right, we're seeing a doctor for some disease and trying to correct it. Now, the last bullet I have here, every system of the body is concerned with maintaining homeostasis except one. And I agree with that, but I'm going to make it a little bit of an adjustment with that. I'm going to say there is no system that doesn't involve homeostasis because the reproductive system is critical, right, to the making of hormones. And those hormones are certainly, we know, a part of our overall homeostasis. Can we live without the reproductive system? Yes. But is it maintaining our homeostasis? Yes, it is. So I want to kind of amend my statement there. I'll update that next time. But let's say that every system, there is no exception, all systems are involved with maintaining or interacting with your homeostasis. So homeostasis then is the basis of maintaining life, right? We have to maintain a constant blood pressure or relatively good blood pressure. We have to maintain a certain energy level, etc. I mentioned to you in the atom-to-atom continuum that a cell is living and that an organelle is not living, right? So if cells are living, what is it about cells that make them, quote, living? In every textbook of any biology course, I don't care if it's a plant biology, an animal biology, or a human biology course, you will see in chapter 1 some description of what is life. Because after all, biology is the study of life. So we better understand what life is since we're studying it. So what are the characteristics of life? And you'll see this list. It may have 5 or 6 or 7 tenets. It may have slightly different words, but they all boil down to the same idea. Number 1, all living things are composed of cells. It may only be one cell if it's a bacterium, right? But there's at least one cell or more cells involved in life. All living organisms have metabolism. It's a fancy word for saying they take in energy and they use it. So we all have a metabolism. We're all taking in sugar and energy, and our body is using it. Every living organism is responsive to its environment, right? The Windex commercial, the plant moves toward the window that has more sunlight, right? All organisms move. They respond to their environment. Their nervous system is helping to help that happen. Growth and development. All organisms, all living things have a life cycle. They get bigger and they go through a life cycle. And then they all reproduce. They make more of themselves. And finally, along the way, they are maintaining their internal environment. They're maintaining their homeostasis. So that's the basic list of things which are living. Okay? So we're living. Bacterium is living. All of those characteristics are met. Okay, here we go. So the question I have for you then, if a cell is living, then that means that an individual cell must also meet these same standards, right? That list I gave you a moment ago was for the entire organism. But a cell is living, it must also have the same characteristics. So let's think about it. Does a cell have its own internal environment? Right? A cell has its own homeostasis has its own metabolism. It takes in energy and it uses it. Every individual cell responds to its local environment. It's being influenced by its neighboring cells and by hormones. Every cell is itself made up of complex organization, like the organelles that make up cells, and every cell will divide to make more of itself. So this is why cells are considered living, because they meet this basic list of life. So the question I want to ask you is this egg alive? This is your basic chicken egg that you bought at Meijer's. Is this egg alive? And I'll just wait for some responses.
Like the egg itself.
Mm-hmm. It's a cell, right? Does everyone agree that the egg is a cell? Yes? So is it living? Can it make more of itself? Not without help, right? So can it respond to the environment? Not really. So it doesn't really meet all the standards of life, does it? But it is a cell. I mean, it's clearly an egg cell. If you were to ask a biologist, it's an egg cell. What about sperm? Are they living? They're just the other half of the equation, aren't they? So everyone says, oh, they wiggle, so they must be alive, right? No. I mean, can they reproduce on their own? Can they respond to their environment? Yeah, they do respond. They're heat-seeking missiles. But basically, we see that the line of life in cells is a little bit crooked. Okay? And this whole conversation gets really complicated when you try to define what is death, right? Because death is the absence of life. Well, what is life? So that becomes kind of philosophical and everything else. But I want you to see that we'll talk about sperm cells, we'll talk about egg cells, we'll talk about even red blood cells. Red blood cells, I'll tell you now, don't have a nucleus. They don't have any DNA. They can't divide. They can't make more of themselves once they're produced in the bone marrow. So red blood cells themselves also really don't meet the standards of life from a purely biological standpoint. It's just kind of a fun conversation. So just know that although we say that egg and sperm are cells, they don't really quite make the mark, do they, as most cells. Okay, in the last few minutes, let me just tell you a little bit about negative feedback. This, again, is a very key concept in physiology, and I told you this is how your homeostasis is maintained. Here's the idea. I'm going to use temperature in your house as the example, but I could also be talking about your body temperature, your blood pressure, your heart rate, all of those things could also be described. And tell me what happens, let's say it's summertime and it's a hot day out, so what do we have? If we have an air conditioner in the house, what happens? We set the thermostat and it starts getting warm in the house, so what happens? Temperature's going up, so the AC kicks on, doesn't it? There's something that perceives the temperature going too high. So now the AC kicks on and now the temperature starts to go down. If you have the thermostat set at 75, does it stop at 75? No, it cools it down a little bit below that, doesn't it? So maybe it cools the house down to about 73 and then it kicks off. And then the temperature starts to rise again, doesn't it? Okay, to some point where it comes back down. So what you end up with is this up and down curve, right? And that's basically how your blood sugar, your heart rate, your blood pressure works. There's a normal range that your body keeps it within. Again, if your body can't keep these parameters within that normal range, then we have a name, some disease for it. So here is sort of the sketch of this. Now, the idea of negative feedback is that there's always a correcting mechanism. So here's my optimum environment. It could be temperature, blood pressure, glucose. And it drops down. And as it drops down, it reaches some point and something in the body kicks it back up. Some hormone is released, some mechanism comes into place, and now it starts to rise back up. Right? So it goes back up. and it overshoots, right? It overshoots, and it gets to some point though, and now again there'll be another correcting mechanism in place. There'll be another hormone or another process within the body that'll bring it back down. It's like your thermostat in your house, heating your AC, or any other system. So the fact that your, whatever this is, blood pressure, glucose, whatever it is, stays between these two lines, right? This is your normal range. Now, when it starts going too low, or when we no longer can correct the mechanism, then we've got a problem, don't we? So then it's a disease of some sort, or something that we can't well control. Now, that's negative feedback. There is also in physiology a thing called positive feedback. I think this is a little bit confusing. So let me describe this to you. Positive feedback is when the temperature starts to get off, it keeps on getting worse. Positive feedback is when the deviation begins, it increases, it snowballs, it gets worse and worse and worse. And there aren't that many examples of this, but one of them would be during childbirth. When the uterus begins to receive the signals for childbirth and the hormones are being released, telling the uterus to contract, there really aren't too many mechanisms. The body doesn't try to stop that, right? The body's natural processes say, okay, it's time for childbirth, and the uterus continues to squeeze and the baby is born. We have to go to the doctor, right? We have to go to the hospital to have emergency things done to stop that process in a woman who's in early labor. But the body itself doesn't have any mechanism to stop labor once it begins. So it's a positive, what we call positive feedback. Number two, milk flow also is this way. Once milk is let down from the breast, it also continues. There's really no mechanism to stop the milk let down. And finally, the third example of positive feedback I want to show you is what happens in excessively low blood pressure. So in this diagram, the dark blue area is your normal blood pressure. Right, this is the area that you want your blood pressure to be. So imagine, it's just been kind of going on like this all the time, just up and down, up and down. That's normal. But something happens right here, and the blood pressure starts to drop. Now, likely what's happening here is someone's bleeding. They're bleeding a lot. They've got a hemorrhage, they're bleeding out, they're losing blood, and the blood pressure as a result is dropping. What would you want to happen? Stop the bleed. Right? But if it's a major, you've cut an artery and there's a major bleed, the body has no way of plugging that up. Someone can come along and apply pressure and stop that externally, but the body has no way of stopping that major bleed. So what happens? The blood pressure continues to drop and drop and drop because there's no way to stop that bleed. Now, while this isn't a positive outcome, this person's about to die, right? It is an example of positive feedback. So you see the idea that once the thing, whatever it is, starts to go outside of its normal range and it continues to snowball worse and worse and worse, or continue to a completion, another way of thinking about it, when it continues to completion, now we're talking about positive feedback. What's that? In this case, right, low blood pressure is not a positive, right? This person's dying if they're hemorrhaging out. Now, if you're talking about uterine contractions in childbirth, that's a happy moment, right? But that's a moment of positive feedback. Negative feedback, what would happen? Negative feedback, which is what 99% of the examples of the body are, once it started to get away from normal, there'd be something that would kick it back, right? If it got too high, it would push it back down. If it got too low, it would push it back up. And we'll see the interaction of hormones and other things later in the course. The last 4 slides are basically imaging. I don't believe this is in your book, but I want you to know that when you open up a textbook or when you go to the literature, you're going to see x-rays and sonograms and CAT scans and MRIs and PET scans. And I want you to have a basic idea of what these different imaging techniques are. Is anyone here going into radiography or imaging? Okay, so you'll know all about this really soon, okay? So we've all had an x-ray probably. An x-ray does what? Passes x-rays through the body, and what it does is the x-rays pass through soft tissues and are absorbed by denser tissues like teeth or tumors, and so you can see those on the x-ray. The danger is that you're absorbing a lot of x-rays, and too much x-ray exposure can be dangerous. Number 2, sonography. Here you're not using x-rays, you're using ultrasound. You're using high-frequency sound waves that are going to reflect off internal organs, and I need to update this because now these can be very, very sharp. With some computer enhancements, sonograms are incredibly sharp images. That's come a long way in the last few years. The good thing is there's no harmful x-rays, and it doesn't have much damage to the baby or whatever it is you're looking at. There are CT scans or CAT scans. You're back to x-rays, but these are lower intensity x-rays, and you're using a computer. That's why it's called computed tomography, or it's using a computer to make these slices. And the nice thing about CT scans is that the computer can create these slices that allow you not to have overlapping bones. So in an x-ray, if you're taking an x-ray of an ankle, you've got bones in there that are blocking other bones. In a CT, you'd be able to slice through and see everything and not have overlapping conflict. There are MRIs. This is using high energy magnets, and basically what those magnets are doing are realigning the protons in the tissue. These are great. MRIs are great for soft tissue. So CTs are great for hard tissue, like bony things. MRIs are great for soft tissue and very, very sharp images. And then lastly, there are PET scans. And PET scans use radioactivity. So what one would do is they'd be given an injection of radioactive glucose or something like that. Now, glucose is a sugar. It's taken up by all the cells in your body. And we now use a computer scan, and cells that are really super active are going to take up more of this radioactive glucose. So if you have a tumor, right? A tumor is a rapidly growing set of cancer cells, and those tumors are going to take up more of the glucose, and on the computer image, you would see a hot spot, right? You'd see more of this radioactive glucose taken up, indicating that this person has a tumor. Now, a PET scan, though, can also be used to look for damage. Let's say someone has had a stroke, and now we're looking for areas of lifelessness, right? We're looking for tissue that's been damaged. So in a stroke or in a heart attack, and you're looking for damage to the heart muscle, you would use a PET scan, but now you'd be looking for blue cold zones, okay, in the computer-enhanced image. So just know that PET scans are using radioactivity to look for either highly active or dead tissue areas. And that finishes up Chapter 1 for us, what I'm calling Chapter 1. Please, I forgot, it's my fault, I didn't get into mastering with you. If you're having any problems with mastering, let me know. But go into Blackboard, click on the Mastering AMP link on the left-hand side, and then register your code, and then you'll see the mastering assignment. Please get that done by Thursday, and then I'll go through it on Thursday more deliberately, because there are some assignments due on there by the end of the week. So if you haven't gotten hooked in by Thursday, if you're having trouble, or tomorrow in lab, come see me and let's get you hooked in there so that there's no, you're not getting behind on anything. And I'll give you instructions on how to view this video on YouTube.